Trig identities are actually one of my favorite parts of pre-cal. But at the same time, they are probably one of the most challenging parts. They are not hard, but they are challenging. So a conditional identity is something that is basically sometimes true. For example, x plus 3 is equal to 5. That's only true if x is equal to 2. 2x is equal to 12 is only true if x is equal to 6. Identities. So what we're looking for is identities that will always be true, or will always be true with valid replacements. So to understand a few basic trigonometric identities, let's go back to the unit circle. Yeah, so our job is going to be to complete the table on the next page. For example, the identity shown above is the ratio or quotient identity because the tangent is equal to the quotient of sine divided by cosine. We also have a couple of other identities that we've also learned. They're called the reciprocal identities, which you guys should be familiar with at this point. So when I say reciprocal identities, what I'm talking about is this. Sine of theta is equal to y divided by r, and cosecant of theta is equal to r divided by y, r just meaning the radius. And so sine is going to be equal to the reciprocal of cosecant. So basically this is saying that sine is just the reciprocal of cosecant. We also have something known as the Pythagorean identity. And the Pythagorean identity is probably going to be the most important identity that you guys will learn. Let's look at this unit circle. Let's say that I have a triangle right here. What kind of triangle is this? Okay, so I have a right triangle, and if I wanted to know the radius of this, what is the radius of this? Why is it 1? Because it's a unit circle. So the radius of a unit circle is always going to be 1, right? What value would you say that this is? X or y? Y. And y is equivalent to what trig identity? Or what trig equation? Trig function? Sine theta, right? So y is equal to the trig function of sine theta. And then this one is going to be x, which is equal to cosine theta. So here's where we get our Pythagorean identity from. If I were to try to figure out what the length of one of these sides is, I can use the Pythagorean Theorem, which is a squared plus b squared is equal to c squared, right? We're going to go ahead and plug in some of the values that we have here. Specifically, I'm going to say, okay, well, I'm going to make cosine theta be equal to my a, sine theta be equal to my b, and this is going to be my c. So I'm going to have cosine squared theta plus sine squared theta going to be equal to 1 squared. What's 1 squared? Right, so we end up with this identity that should be true for any valid theta. Cosine squared plus sine squared will be equal to 1. We can actually even try this out with these. This is my cosine, right? This is my sine. So let's see what happens. 1/2 squared plus square root of 3 over 2 squared is equal to, well, 1 squared is just 1, 2 squared is 4, so 1 over 4 plus square root of 3 squared is 3 plus 2 squared is 4. So 1 over 4 plus 3 over 4 is equal to 4 over 4, which is equal to 1. It should work with any valid theta. So within the unit circle, this trig identity will always be true. Let's start with the reciprocal identity. So secant of theta is equal to the reciprocal of what? 1 over cosine theta. Cosecant is the reciprocal of? And what is the reciprocal of cotangent? Tangent, right? So these are some that you guys basically already know. If tangent is equal to sine over cosine, what is cotangent equal to? Cosine over sine. Now, these you may not realize that you know at first, but you actually do because you've never seen it written out this way. Sine times, it's not cosine. It's not times tangent. It's times cosecant. And let me show you why. Because if you have sine of theta times cosecant, it's like 1 times, like x times cosecant theta is equal to 1. If I convert this into terms of sine and cosine, I'm going to take sine theta times 1 over sine theta and this is sine theta over 1. Guess what? The signs just cancel out, and I get 1 over 1, which is 1. So what can I multiply times secant to get 1? Right, it's reciprocal, which is cosine. And what can I multiply times tangent to get to 1? The reciprocal, which is cotangent. My Pythagorean identity, guys, what is it? My original Pythagorean identity. Go ahead and say it.
Cosine squared.
Cosine squared. Awesome. So I'm going to go ahead and separate this out into two different identities. So what I'm going to do is I'm going to go ahead and work with the original Pythagorean identity. Now, what I'm going to do here is I'm going to take this and I'm going to divide this side by cosine squared theta, and I'm going to take this side and I'm going to divide it by cosine squared theta. What we do to one side, we have to do to the other. That's basically the number one rule of algebra. So if I divide this side by cosine squared theta, I have to divide this side by cosine squared theta. And then what I'm going to do is I'm going to divide each one of these trig functions by cosine squared theta. So I'm going to take cosine squared over cosine squared. What would that give me? Cosine squared over cosine squared. They cancel out. That gives me 1.
I know.
Now, what's sine squared over cosine squared? So 1 plus tangent squared theta is equal to what's 1 over cosine squared? It's secant squared theta. All right. So to recap, this is what I did. I took the original equation and I divided everything by cosine squared theta. Cosine over cosine, that gives me 1. Sine squared over cosine, well, that's just an identity that we were just looking at. That's sine over cosine. That's equal to tangent. And then 1 over cosine is the same thing as its reciprocal function, which is secant. So this is another trigonometric identity that will always be true no matter what. 1 plus the tangent squared theta is equal to secant squared theta. I can do the exact same thing. Exactly. But I'm going to divide by sine this time. I'm going to divide this side by sine and this side by sine. What's cosine divided by sine? It's cotangent squared theta. What's sine over sine?
1.
And then what's 1 over sine? What's the reciprocal of sine? Cosecant squared theta. And so here I have the other reciprocal function. So I want you guys to go ahead and add these to your chart right here.
I already written down.
Here we have 1 plus tangent squared theta is equal to secant squared theta. And then cotangent squared theta plus 1 is equal to cosecant squared theta. So the point of this is when we are trying to solve for trigonometric equations, we are going to simplify expressions using these identities. This is going to be our original expression, and whenever you have an expression that you want to simplify using trig identities, your first step is usually, not always, but usually is going to be to turn things into terms of sine and cosine. What do I mean by that? Cotangent can be represented as cosine over sine. When you represent it this way, you can see that since this is sine over 1, what happens to the sines? They can cancel each other out, and you're left with cosine theta as your answer. So sine times cotangent is equal to cosine. Now, they're not always going to be this simple, but they're not always going to be difficult either. Now, let's review some of these identities. Cotangent of theta. What is an identity for cotangent of theta?
Cosine over sine.
Right, you could say that this is cosine theta over sine theta. What is an identity for tangent?
Sine over cosine.
Sine theta over cosine theta. What is sine squared plus cosine squared?
1.
Sine squared plus cosine squared. How do I know that that's 1? Guys, they're all coming from right here. So secant is 1 over cosine theta. What's 1 over cotangent?
Tangent.
This is tangent theta.
1 over sine.
Cosecant is 1 over sine theta.
Oh, there's more. So kid memorize all these?
Huh?
So kid memorize all these?
Yeah, but these all stem from this. So as long as you guys know this, you guys should be good. Look, if you guys aren't sure what to do, your first step is always going to be to turn things into terms of sine and cosine. So sine theta times cosecant. Well, cosecant is just 1 over sine.
We do the same thing as 1.
So what happens to the sines?
They
They
cancel out.
divide, and it's a 1 now.
So my answer is?
So that's
When?
1.
What is 1 over secant? Yes, I want you guys to get used to writing your work.
Cosine.
This is equal to cosine. Let's look at number 9. Cosine theta over cotangent theta.
So it's cosine over 1 times 1 over tangent.
Cosine over 1 times, not 1 over tangent. You guys want to go ahead and put this in terms of sine and cosine. So
Cosine over sine.
So cosine over 1 divided by cosine over sine.
Times sine over cosine.
So you could say something like cosine over 1 times sine over cosine. What's going to happen?
Sine over 1 is what sine. Cosines are going to cross out cosine.
So this is equal to sine theta.
I feel like a little kid is putting all the blocks in different shapes.
Wait, what is second again? Would 10 be cosine? Wait, you need to go back to 8.
All right. This number 8. It's an identity in and of itself. Right? Secant is equal to 1 over cosine, which means that 1 over secant of theta is equal to cosine. The opposite is true. So you could say 1 over cosecant is equal to sine, and 1 over tangent is equal to cotangent. Right?
Oh, right.
These two correlate with each other. So that's how I was able to solve number 8 fairly quickly. Let's look at 13. We have secant theta times cosine theta. So remember, if you don't know where to start, turn things into terms of sine and cosine. Secant, how can you denote secant as sine and cosine?
1 over cosine.
It's the same thing as saying 1 over cosine of theta. And then you're multiplying it by cosine of theta. Technically, it's over 1. So what happens?
We learned about reciprocal identity.
Yep. What are your steps? Step number 1, it's to do what? What is your first step?
Change it to sine and cosine.
Change it to sine and cosine. Change to sine slash cosine. That's going to be your first step for these. If you don't know what to do, change it to sine and cosine.
Wait, what is 1 over sine squared? Is it cosine times sine? Wait, for 18? Because there's a squared, but they don't cancel out, do they? I'm confused. I get sine over cosine times 1 over sine squared.
So,
So what? Oh, 1 over. So.
Wait, yeah, 18, yeah. Oh, that's.
this would be your answer.
Why?
So for number 18, let's look at it. What I did was I took tangent and I converted it to terms of sine and cosine. So tangent is sine over cosine. I took cosecant squared and I actually separated this out. You could say cosecant squared is the same thing as cosecant times cosecant.
Nice.
Cosecant times cosecant. Cosecant being 1 over sine. So I take sine over cosine times 1 over sine times 1 over sine. Well, that means the sines cancel out, or at least one of them does. And I get 1 over cosine times sine. Well, 1 over cosine is just secant, and 1 over sine is just cosecant. So my answer is just secant times cosecant.